Okay. So today we will start our session. I think in last session we have discussed about this one-way slab. Now today we will discuss two-way slab and then we will proceed for the beam. So basic things means how to calculate the loads and then how to calculate the bending moment and reinforcement that we have discussed for the single one-way slab. Okay. But if you see in two-way slab, so basically in two-way slab we are providing the main reinforcement in both direction. So we have to calculate the bending moment in both direction. Basically to calculate the
Hello,
load or the load criteria. Yes, hello. Am I audible now?
sir. Screen is not visible, sir.
Screen is not visible. Just wait. I
Yeah.
have not shared any
Yes, yes, yes.
screen.
Okay.
It's showing
Yes.
you are presenting. Yeah, yeah.
Yes. Now I think it is okay.
Yes, sir. Now it is visible. Design of
Yes.
two-way slab.
Yes. Design of two-way slab. So
Yeah, yeah.
basically, see, in one-way slab, we have considered the bending moment, or we are providing main reinforcement only in one direction, means shorter span. But in two-way slab, we are providing the main reinforcement in both direction, means longer span as well as shorter span. So in that case, we have to calculate the bending moment in both direction, means Lx and Ly. So while calculating the bending moment, some guidelines are given in IS 456. So that guidelines we have to follow. Okay, and some formulas are given that we will discuss how to calculate the bending moment in X and Y direction. So only that difference is there, means if you compare the one-way and two-way slab as a design point of view, only difference is in calculation of bending moment, because in one-way slab we are considering simply supported slab, and simply supported bending moment for the simply supported slab we can directly calculate by using WL square by formula. But in two-way slab we have to calculate the movement in X direction and movement in Y direction. So two formulas are there, that is alpha X WD into Lx square, and in Y direction formula is alpha Y WD into Lx square. Okay, so in moment in X direction and moment in Y directions, first we have to calculate this coefficient. Okay, movement coefficients in IS code, actually detailed specifications or detailed what we can say introduction is given. So as per that we will calculate alpha X and alpha Y. Basically that alpha X and alpha Y are the moment coefficient for the moment X, and alpha Y is the moment coefficient for the moment Y, and it's depend on the Ly by Lx ratio. So while calculating or while deciding the types of slab, first we are calculating this Ly by Lx ratio, and then we are deciding whether that slab is one-way slab or two-way slab. Similarly, that Ly by Lx ratio we will use to calculate the alpha X and alpha Y. So how to calculate it, that we will discuss. Okay. Okay, so we will proceed for the design. Some basic steps are same as the previous that we have discussed. So now here, let's say suppose this S4 slab we are designing over here, and if you see for the two-way slab, first we have to decide the edges of the corner, means we have to focus on the edges of the corner, means two adjacent edges are discontinuous. 9 cases are there as per the IS 456. 9 cases are there. That 9 cases also we will discuss. Okay, so as per that we have to decide which condition is satisfied in our slab. Okay, so that we have to focus, so that we will discuss. So S4 slab we are considering over here. Okay, this slab. Okay, so this is our given data, means that we have assumed grade of concrete M20 concrete we are using, steel Fe500, clear cover 20 cover we are providing. Dimension of slab, okay, this is the dimension of slab that S4 slab we have considered over here, and dimension is 3050 in and 4180 in Okay, means if we see, this is our Ly, longer span always we will consider as a Ly, and shorter span as a Lx. Okay, so Lx is equals to 3050 and Ly equals to 4180 in These are the dimensions of slab. Now next, assume beam support. Okay, so whatever beam support is there, so we are considering that beam support means width of beam is to 30 that we have provided, and unit weight of concrete is 25 kilonewton per meter square. So these are the dimension, these are the given data that we have with us to design particular slab. So first step, as usual, calculate the aspect ratio. Okay, and if Ly, we know that if Ly by Lx ratio is less than 2, it means that particular slab we have to design by considering the two-way slab. Okay, so now here Ly is 4180, Lx is 3050, so that ratio is 1.37, and that 1.37 is less than 2, so that particular slab we will design for the two-way slab. Okay, now again we have to decide the modification factor. Okay, for the deciding modification factor and the required depth, first we have to consider the basic value, and as per the IS 456, okay, as per the IS 456 page number 37, so L by D ratio is given, that already we have discussed in last session. For cantilever L by D is 7, for simply supported L by D is 20, and for the continuous, okay, L by D is 26. So why we are considering this slab as a continuous slab? Because if you see over here, so S3 and S4 means whatever reinforcement we are providing in S4 slab, that reinforcement will continue to S3 slab, okay, in this direction. Similarly, this S4 and S4 slab, both slab are connected by this B9 beam. So whatever reinforcement we are providing in this slab, so that reinforcement will continue to this slab. Correct. So that's why the particular slab we are considering as a continuous slab. Okay, and for that, for the calculation of basic value, we are considering L by D ratio is a 26. Okay. Now, so percentage, again, that percentage of steel is with us. Okay, 0.25%. So if you want to consider minimum percentage of reinforcement, so we know the minimum percentage of reinforcement for slab is 0.12%. So if you want to go with this 0.12%, so no problem, we can do it. Okay, but now here standard we are considering 0.25%. Then modification factor is 1.35. Okay, so as per the reinforcement and this graph, that I think graph we have already discussed in one-way slab. See, this is the graph that we have discussed. So now here, first we have to calculate the FS value. Okay, and for FS value we required reinforcement required and reinforcement provided. But now here we have not calculated any reinforcement, so we will consider that ratio is 1, and 0.58 into Fy. Fy is 500 because we have considered 500 grade of steel. So 0.58 into 500, so it's 290. Okay, so as per this percentage of reinforcement, tension reinforcement 0.25, and this Fs equals to 290 line, our modification factor is 1.35. Okay, so now by using this graph we have calculated the modification factor 1.35, and that we have considered over here 1.35. Okay, and then effective depth formula, span divided by basic value into modification factor. So by putting the values, now span, while considering the span in two-way slab as well as in one-way slab, we have to consider the shorter span. Okay, means whatever design we are doing for the one-way and two-way slab, so it's totally based on the shorter span. Okay, so that's why here span we will consider 3050, that is our shorter span Lx. Basic value is 26, 26 should be there. Basic value 26, and the modification factor is 1.26, and modification factor is 1.35. So required depth as per the span, basic value and modification factor is 86.89. Okay, now after that design, consider the diameter, and then clear cover already we have considered, that is 20, and then calculate the overall depth. So if you consider 8 mm diameter, 20 mm cover, and this 86.89 effective depth, so our overall depth is 110. Okay, so if you want to go with this depth, so you can go, no problem. But generally in field also we are not providing effective depth less than 100 mm. Okay, effective depth less than 100 mm, that we are not providing, so that's why we will increase it. Okay, so round off we will consider 125 mm. Okay, and by considering this 125 mm, again we have to calculate the effective depth. See, therefore the provided effective depth is d minus cover minus 8/2, that is 101. So now it is okay. Okay, so as per the revised calculation, our provided effective depth is 101 and provided overall depth is 125. Now these depths we will consider for the further calculation. Now next effective span, same that we have already discussed in one-way slab, Lx plus bearing and Lx plus D. Okay, so consider minimum from these two. So if you consider Lx plus bearing, so L is 3280 and Lx plus D, that is effective depth, it is 3150. So consider minimum, and a minimum length is 3151. So that we will consider as a effective span. Okay. Now after that, load calculation. Okay, so in load calculation, first is sulphate of slab, second one live load, and third one is additional dead load coming on our slab. Okay, so first sulphate of slab, dead into unit weight of concrete. So depth is 0.125 overall depth, and unit weight of concrete is 25. So that sulphate is 3.125 kilonewton per meter square. Now live load, actually that live load is depend on, if you refer this IS 875, that live load is depend on the purpose of your room. Okay, so it is different in different room, but basically we are considering 2 kilonewton per meter square. So live load is 2 kilonewton per meter square, and SIDL is floor finish. Okay, now if you compare with the last session, means in last sessions we have considered one-way slab for the toilet.
Sir, can I ask a question, sir?
Sorry, yes.
Sir, this live load, can we consider, is it considered the workman's during pouring also?
No, actually in live load we are not, yes, actually in the live load we are not considering the workman. Means whatever workers are doing their work on the slab, that load we are not considering.
Because during pouring, sir, there will be a lot of workmen and engineers and supervisors supervising the work.
Yes, correct. Yes.
Are we considering that, sir?
No, actually we are not considering that. Okay, so basically reason, yes,
sir.
Yes. Basically reason behind that, so now here we have considered live load as a 2 kilonewton per meter square. Okay, but it is okay, so many workers are there while pouring the concrete and doing the casting of the slab, but in the design point of view, for the design point of view, we are converting this live load by 1.5. Correct.
Sir,
okay.
Sir,
Yes.
In that time, load transferring to settling material, sir, not to the slab during pouring, sir. We have to design settling. That's why you are not considering, sir.
Correct. That is the one factor. Okay, so that I am discussing. This is our first factor.
Okay,
first
sir.
factor is what we have convert that live load to the factor, means already 50% margin we are considering over here. That is one thing. Okay, and second thing, while casting any slab or any member, generally we are considering their settling. Okay, settling is there. Okay, so means if any maximum load is there, okay, so that load will resist by the settling, means load is directly coming on our settling. Okay.
Okay, sir. Okay.
So now if you compare with the one-way slab, in one-way slab we have considered that particular slab for the toilet. So for toilet, sunk is there, but now this slab we have considered for the one room. So sunk is not there. So if you see over here, we have considered only screeding and the flooring. Okay, screeding is 50 mm and the flooring is 10 mm. Okay, here we have not considered, again I repeat, here we have not considered the sunk slab or sunk weight, because sunk will come only in the toilet and bath basically. Okay, so that's why in super dead load or superimposed dead load we have considered only two load, screeding and flooring, and for these two load our total SIDL or SDL is 1.5 kilonewton per meter square. Okay, now calculate the total load. 3.125 plus 2 plus 1.5, that is 6.625, but that load is a working load, that is 6.63 approximately. So convert in design or ultimate load by multiplying 1.5, so it's 9.945. So consider approximately 10 kilonewton per meter square. Okay, so now the total load on slab is 10 kilonewton per meter square. So this is just example how to consider the live load or the imposed load for the residential building. Okay, for hall room and kitchen 2, toilet and bath 2, corridors, passages, staircases, including the storeroom 3, balconies 3. Okay, like that. Okay. Now, once you calculate load, next step is calculate the bending moment. Okay. Now, if you see IS 456, so this Annex D, okay, clause number 24.4 and the 37.1.2, slab spanning in 2 direction. Okay. So restraint slab means generally that slab is called as a restraint slab. So bending moment for the restraint slab is in x direction alpha x w lx square, and my is equals to alpha
Hello,
y
sir.
w. Yes.
I want to ask one question.
Yes.
Whenever there is a two-way slab, and if on that slab there will be the wall for 1 or 2 meter, which is not having a beam beneath that, then how we can consider that load from that wall?
Okay, actually that I think that questions already I have given answer in first session, correct? Because basically whatever wall we are considering, okay, so as a
Mhm.
structural engineer point of view, we have to consider the beam below the wall.
Yeah, exactly. But at some cases, there will be no beam, only coping has been used. So that's why my question is for that.
No, actually such type of provision is not there. Means as a structural point of view, means if you uh, see the structural point of view, that such type of things I will not allow. Okay, first. Okay,
Okay, okay.
is if any slab is there, whatever slab, 2-inch, 5-inch, 3-inch, 9-inch, whatever slab you are wall you are providing. Okay,
Mm-hmm.
so we should be consider beam below the wall. Okay, as a structural point of view. But yes, if in some cases suppose such type of loading is coming, okay, but actually it is not allowed as a structural point of view. And if you see or if you refer any book, okay, such type of design you cannot find. Okay, if you see the design such type of slab. Okay.
Okay, okay, sir.
Yes, yes. Okay, okay, so we will continue. So calculate the moment in x and y direction. Okay, these are the formulae: alpha x alpha y w l x square. And whatever reinforcement we are providing generally as a theoretical point of view, first we will discuss theoretical point of view and then we will proceed for the practical point of view. See, in theory generally we are considering middle strip and the S strip. Okay, means if you consider, let's say suppose this is our lx and ly direction. So first we have to divide our total slab in 3 strip or in 3 part. Okay, last part is the S strip. Okay, and this is our middle strip. Similarly in another direction also, means in both directions generally we are considering middle strip and S strip. So if you combine both, so your slab should be like this. Okay, just wait. Let's say suppose this is our total slab, and now in this direction A strip like this. So this is our middle strip and this is A strip for both in both direction. Okay, means whatever reinforcement we are providing, that main reinforcement, okay, so that main reinforcement should be in the middle strip only. Okay, and the distribution steel, we can provide distribution steel in A strip. Okay, in this strip, A strip. Okay, so in both direction. Okay, in both direction, main strip, main reinforcement in middle strip. Okay, and whatever corner is there, so at that corner we are providing the torsion reinforcement. Okay, in this corner we are providing the torsion reinforcement, and that torsion reinforcement is depend on the continuity of your slab. Okay, the torsion reinforcement is depend on the continuity slab. If you see over here, Some clauses are there. This torsion reinforcement shall not provided at any corner where the slab is simply supported on both edges, meeting at the corners. It means if there is no any continuity of your slab, so torsion reinforcement is not required. If slab is continuous, so torsion reinforcement should be provided. So this torsion reinforcement we will calculate as per the edges. Okay, that is L by 4, L by 2, LX, LX by 4, LX by 2, and LX only. Okay, so these are some theoretical formula to calculate the torsion reinforcement, but practically we are not providing reinforcement like this. Okay, we are providing whatever reinforcement we are calculating, that reinforcement we are providing in all the slab. Means we are not focusing on the middle strip as well as A strip. So such type of reinforcement we are providing, or either we are giving such type of detailing of two-way slab to the site. Okay, so my question is, why we are doing it? Means theory or IS code is saying that we have to provide the torsion reinforcement over here, but practically we are not providing it. So any what you can suggestion from your side, why it is so? आना चाहिए ना, क्वेश्चन आना चाहिए. क्वेश्चन बराबर है मेरा?
Yes, sir. Yes, sir.
क्वेश्चन बराबर है. क्वेश्चन समझ में आ गया मुझे क्या पूछना है कि हम
Sir, actually,
we already providing extra reinforcement on the beams, so
extra
that can be
reinforcement on the
on beams.
extra
beams.
extra top,
Okay,
Yeah, just
extra
above the
top
beam from
reinforcement,
the.
sir. Generally, we providing extra top reinforcement, sir. That's why it
extra
also
top
count.
reinforcement.
Yeah,
Correct.
L by 3 square.
Yes, correct. Generally, we are providing extra top reinforcement at the continuous edges. So if you see the torsion reinforcement, maximum torsion reinforcement is 0.5%. Okay, means 50% of main reinforcement maximum. Correct. So while providing this while providing this main reinforcement in both directions, we are providing alternate Benta bar. Correct. We are providing the alternate Benta bar. Means already we are providing 50% reinforcement at top of the slab. Correct. Why we are providing this torsion reinforcement, or what is the aim of the torsion reinforcement? Yes, anyone can reply. Why we are providing this torsion reinforcement?
To resist the uplift
To resist
of
the uplift.
slab
Correct.
at
To
the
resist
corner.
the uplift. Correct. So for the resisting this uplift of slab, we have to provide the reinforcement on the top of the slab. Correct. बराबर है. अगर यहाँ पे अगर मैंने ये स्लैब कंसीडर किया, लेट्स से दिस इज आवर स्लैब, अगर यहाँ पे अपलिफ्ट मुझे रेजिस्ट करना है, सो आई हैव टू प्रोवाइड द टॉप रेनफोर्समेंट. करेक्ट. And already we are providing the top reinforcement, 50% top reinforcement in or at the support of slab. That's why this torsion reinforcement is not required. In practically, generally we are thinking like that. Okay, but theoretically, yes, theoretically we have to consider the torsion reinforcement at the particular edges as per their condition. But practically, already we are providing the 50% reinforcement at the top. Extra reinforcement also we are providing. So the torsion reinforcement is not necessary. Okay. So,
Sir, I have one query, sir. Sir, actually, I have seen many design, they do not follow alternate bent up schedule.
Alternate bent up schedule, they are not following it.
Yeah. Actually, in a DLF, sir, I have do some project, J+23 project.
Okay.
They have provided extra top bar, and they do not alternate bent up. They just pass through the beam as a continuous slab.
Yes, in the continuous slab. Okay.
Yeah.
Now see, in beam also we are doing this. If you see the detailing of beam, correct. Let's say suppose, sorry. Let's say suppose this is our continuous beam. Okay. So in beam also, generally suppose this is our middle support. So in this also we are providing the extra top reinforcement. Okay. If you see the previous design, means I think before 5-2 6 years before, we are providing the bent up bar in beam, correct?
Yes, sir. Yes, sir. Yes, sir.
Okay, we are providing bent
Yes,
up
sir.
bar in beam, but currently no one are using this method. All structural engineer are using the only straight bar at the bottom, correct?
Yes, sir. Yes, sir.
Okay, and they have reduced this, means they have neglect this bent up bar with the extra top reinforcement. So maybe some structural engineer have that method in slab also. Okay,
Yes,
maybe.
sir.
See, whatever design we are doing over here, or whatever
Actually,
detailing procedure is there, that detailing procedure or the design is totally based on the structural engineer. Okay,
actually, they
so
giving reason that's to resist earthquake load. In
to
cases of
reduce
earthquakes,
earthquake,
load. In cases of
load.
earthquake, yeah.
Hmm.
In cases of earthquake, all the load parameter will be, sir, मतलब अपोजिट हो जाता है सर एट द सपोर्ट पे अपवर्ड मोमेंट जनरेट होने लगता है अपलिफ्टिंग मोमेंट
बराबर बराबर.
हाँ और
So see,
बॉटम पे जो मेरा लोड हाँ
जनरली कैसे रहता है
लोड
कि जब हम डिजाइन करते हैं, बीम डिजाइन करो या स्लैब डिजाइन करो, सपोर्ट पे जनरली हम क्या करते हैं, हम जो भी बेंडिंग मोमेंट यानी कि जो भी हम मेन रेनफोर्समेंट कैलकुलेट करते हैं, वो मेन रेनफोर्समेंट हम बेंडिंग मोमेंट जो मिडल पे है उसके हिसाब से कैलकुलेट करते हैं, करेक्ट?
यस सर
ओके, सो उसके बाद में हम क्या करते हैं कि लेट से सपोज यहाँ पे बेंडिंग मोमेंट, जस्ट फॉर एग्जांपल, लेट से यहाँ पे मेरा बेंडिंग मोमेंट 50 है मिडल पे, और सेंटर पे में भी 70 है. ओके, जस्ट फॉर एग्जांपल. ओके, सो हम ये जो 50% रेनफोर्समेंट यहाँ पे प्रोवाइड कर रहे हैं, मतलब इससे रेनफोर्समेंट आ गया हमारा 200. सो 50% रेनफोर्समेंट हमने यहाँ पे दिया, 100 तो रेनफोर्समेंट हम यहाँ पे प्रोवाइड कर रहे हैं, और 70 के हिसाब से हमें रेनफोर्समेंट लग रहा है लेट्स से 250 mm स्क्वायर. ओके, सो 100 mm ऑलरेडी हमने प्रोवाइड किया है, तो हम क्या करते हैं 250 माइनस 100. सो अभी रिक्वायरमेंट कितना का है 150.
150
ओके, सो वो जो 150 है ना, वो 150 mm स्क्वायर हम एज ए एक्स्ट्रा रेनफोर्समेंट करके वहां पे प्रोवाइड करते हैं.
ओके सर
ओके, सो जनरली जो भी हम रेनफोर्समेंट कैलकुलेशन कर रहे हैं एट ए डिफरेंट पोजीशन, ओके, so that reinforcement is as per the building moment developed at that particular point. Means let's say suppose we are designing that particular slab or any elements as per the earthquake, okay, or the seismic load or wind load. So first what we are doing, first we are analyzing that particular element, correct, and then we are checking the behavior of that particular elements by acting all these loads: earthquake load, wind load, gravity loads, whatever loads are there that you are considering for the design. Okay, and as per that conditions we are designing, means we are focusing on the bending moment and then shear forces and then deflections, and as per that all criteria we are designing that particular elements. Okay, all the elements.
So which method is then economical? Is that bent bar method or curtled bar method?
Curtle bar method or
Whatever bent up bar. Right now,
bent up bar
as before 4 to 6 years before, you have been explained that bent up bar have been used, and
method.
right now structural engineers are using that curtled bar. That means they are curtling the bars at the bottom and providing extra top bars at the top level, just above the beams. Okay,
Yes.
so which method is much economical? That means I am asking with respect to the optimization of reinforcements.
Yes, optimization, for the optimization. See,
Yeah.
basically, if you compare these two now, so basically bent up bar is generally required. Means whatever bent up bar we are providing for the slab, that bent up bar generally required to resist the shear forces. Okay, so basically here we are not providing the stirrups in slab, correct? Actually, first we have to see why we are providing the bent up bar. Means is it necessary to provide the bent up bar for slab and beam? And if you not provide the bent up bar for the slab or beam, so what happen, or what is the work of that bent up bar? That we have to focus first, and then we will decide so whether that economical or not. Because see, while considering the optimization of element, okay, so we cannot be focused on only one element, means like only slab, or sorry, only concrete or only steel. We have to focus on overall. Means if we if you provide suppose bent up bar, so what happen if you provide the if you do not provide a bent up bar, so in that case what happen? So that also we have to consider for the design point of view. Okay, that is first thing. Okay, second thing is for the economical process, means which one is economical. Okay, so basically what we are doing over here. Okay, here generally here we are neglecting this bent up bar, or we are replacing this bent up bar with the extra top reinforcement. Correct. So as per my experience, whatever reinforcement, total reinforcement, I am saying total reinforcement. So whatever total reinforcement we are providing, that total reinforcement is nearly equal. Nearly equal. We can't compare the economical and uneconomical with bent up and without a bent up. Okay, so I think why they have replaced it, because see, if we see the reinforcement or the diameter of bar required for the slab as well as in beam. Okay, slab and beam. So generally we are providing maximum number of bars or diameter of bar. Okay, in beam as compared to slab. Generally in slab 8 mm, 10 mm is sufficient. Basically 8 mm is sufficient, but for beam generally we are going for the 20, 16 mm. Okay, so it's very difficult to bend at the proper position or in the proper manner. Correct. Okay, so that's why only for beam we have what we can say replace it for the extra in the extra reinforcement. That is one thing. Second thing, we are providing the stirrups in beam. Correct. And actually that bent up bar we are providing only for to reduce the shear reinforcement or to reduce the shear stresses at the corner. Correct. And if you are providing the shear reinforcement, so no need to provide the bent up bar in beam. That is, as per my experience, that is the main thing to convert bent up bar to the straight bar. And yes, if you see the curtailment, yes, obviously if you provide some curtailment in the main bar, so obviously it is economical.
Okay, sir. Okay.
Okay. Yes. Okay. So shall I proceed?
Yes, sir. Yeah.
Yes. Okay. So now see. So to calculate the bending moment, first we have to calculate the alpha x and alpha y. Okay. And that alpha x and alpha y we can find by using this table 26. So this is our table number 26. Bending moment coefficient for the rectangular panel panels supported on 4 sides with a provision for the torsion at the corners. Okay. So now some conditions are there, 9 conditions are there, and as per that 9 conditions we have to calculate this alpha x and alpha y. Okay, so first here you can see first column serial number or case number is there. Second column types of panel and the moments considered. Next one is the short span coefficient alpha x, values of Ly by Lx ratio as per the values. Okay, so 1, 1.1, 1.2, 1.3, 1.4, 5, 1.75. These are the Ly by Lx ratio. Okay, and long span coefficient, that is alpha y for all the values. Okay, means if any value is there for the Ly by Lx ratio, so for all values we can use this Ly by Lx ratio or sorry alpha y values. Okay, now these are the 9 cases. So first case is interior panel. Second, one short is continuous, one long is discontinuous, then 2 adjacent edges discontinuous, then 2 short edges discontinuous. So like this, all criteria is there, all cases are there. So first we have to decide whatever slab we are designing over here. So which condition for that slab we have to decide. Okay. Now if you see this plan, in this plan, so this edge is continuous and this edge is also continuous. But if you see over here, okay, in this part, so here staircase is there, so whatever reinforcement we are providing for this slab, that reinforcement is not continuous to in this direction. Similarly in this direction also the reinforcement is not continuous, so we can consider 2 adjacent edges are discontinuous. Okay, so these 2 adjacent edges are discontinuous, or these 2 edges are discontinuous. So first we will see which condition is there. Okay, 2 adjacent edges discontinuous, 2 short edges discontinuous. Now here short as well as long, both edges are discontinuous, so we can use these two adjacent edges discontinuous. Okay, now here we will use this fourth case, but now next is LY by LX ratio. Our LY by LX ratio is I think 1.37. LY by LX ratio is 1.37. So that 1.37 is between 1.3 and 1.4. It is between 1.3 and 1.4. So for 1.3, for fourth case, 1.3, 0.065, okay, that is negative coefficient, and positive movement at mids means positive coefficient is 0.049. Okay, similarly for 1.4, 0.071 and 0.053, but we have to calculate it for 1.37. So for that we have to use the interpolation formula. So that we will see for the shorter span, LY by LX ratio 1.3, 1.4. Now we require for 1.37, 0.065, 0.049, then 0.071 and 0.053. Okay, so this is for negative reinforcement coefficient and this is positive. Okay, so alpha minus alpha x is 0.05 by interpolation formula. Okay, minus alpha x is 0.0692, negative moment at continuous. Okay, and immediately calculate the bending moment. So bending moment is 6.836 kilonewton meter, negative, negative moment at continuous edge. Similarly, in shorter span, positive moment alpha x. Now again calculate positive alpha x. So positive alpha x is 0.0518. So moment is 5.117 kilonewton meter. Now this moment is at mid span, that is 5.117 kilonewton meter at mid span and 6.836 at continuous support. Okay, at continuous edges means at support. Okay, similarly calculate for the longer span, negative and positive bending moment with their coefficient. And if you see in this graph, sorry, in table, so for two adjacent edges, alpha y is directly 0.047 and 0.035, 0.04 and 0.47 and 0.035. Okay, so again continue at continuous edge moment is 4.62 and at mid span it is 3.46. Okay, so for the moment, for the depth check, first consider the maximum bending moment only for the depth check. Okay, so now from all the moments, maximum bending moment is okay. Now here neglect positive and negative. Okay, don't focus on the positive and negative moment. Okay, positive moments mean tension at bottom. Okay, and negative bending moment mean tension at top. Only that difference is there. But whatever reinforcement is there, that reinforcement we are calculating as per the value, as per the intensity, not as per the sign. Okay, so maximum bending moment is 6.836 and we will calculate or we will check our depth by considering this maximum bending moment. Okay, and if you see this bending moment, so required depth for the grade of concrete is 50.7 mm, but now here we have provide effective depth is 101. So now it is okay, means whatever depth we have considered or whatever depth we have provided over here, that depth is okay for the bending moment. Okay, now here depth is satisfied only for the bending moment. Okay, now after that calculate reinforcement. Okay, reinforcement again, here we have to calculate the reinforcement at mid span as well as at the support in shorter span and longer span, and we have the different bending moment. Okay, so at support first bending moment is 6.86. Okay, AST is 168 and minimum area of steel as per IS code is 0.12%, that is 150 mm square. So 162 is greater than 150. Okay, so we can go with this reinforcement 162. Then calculate spacing assuming diameter, same criteria that we have discussed in one-way slab. Okay, so 8 mm over 200, that 200 criteria is not given in IS. It is as per our consultancy. Means in our consultancy we are using maximum 200 mm spacing. Okay. Similarly, at mid span, 120. Okay. Now this is 120 is less than 150, so we will go with this 150 mm. Means at mid span, as per this bending moment 5.117, we require 120 mm square reinforcement. Okay. But as per the IS code, we have to go with minimum reinforcement, and that minimum reinforcement is 150 mm square. So that reinforcement we should be provided for slab at mid span. Okay, so we will go with this 150. Then again calculate the spacing for that 150. Then at longer span, same at support and at support and mid span. So again it is less than 150. So provide 150. Then calculate spacing, and then again at mid span. Okay, 87. So 150 mm square should be there. Huh? So again we will go with the 150. Okay, that is one thing. Okay, so now here we have calculated the reinforcement at mid span as well as at the support in longer and in shorter direction. Once you calculate the reinforcement, next is just check the deflection. Okay, means whatever depth we have provided, that depth is okay or not for the deflection that we have to consider. Now here, for the calculation of deflection, basically our formula is depth that we have considered, L by D ratio. Correct. As per the IS code, L by D ratio is equals to 26. Okay. And for the deflection, this formula is L by D 26 into modification factor. Okay. That already we have converted in effective depth equals to L divided by 26 into modification factor, where that 26 is what? It is basic value. Okay. So now for the calculation of modification factor, basically that modification factor is depend on the percentage of steel. Correct. Depend on the percentage of steel and FS value. So for the FS value, we have the AST required and AST minimum now here. Okay. So just calculate that FS, then percentage of steel, then effective depth of the deflection. So percentage of steel AST provided divided by BD, that is 0.25%, because now here we have provided reinforcements 251, maximum reinforcement 251, correct, provided reinforcement. If you see over here, AST provided 8 mm bar that we have assumed, so pi by 4 into 8 square divided by 200 spacing into 1000, that is 251.33 mm square. So this is the reinforcement, and as per that reinforcement, percentage of reinforcement is 0.25%. Calculate FS because we have the required and provided AST. So 162.1 divided by 251.33. So now FS is 187.04. Okay. So use this graph, okay, which is given in page number 38. Okay. And if you see over here, our FS value is 187. 187. So that 187 is in between this 190 and 140. Okay, maybe this line is here, maybe approximately consider this line, and percentage is 0.25. so if you go with this 0.25, so that 0.25 line will meet beyond the graph. Correct, this line will meet to this 0.25% beyond the graph. So higher modification factor we will consider, that is 2. Okay, so provide these 2 modification factor over there. See, modification factor is 2. Then calculate depth, span divided modification factor into basic value, that is 76.25. It is less than provided depth, so it is safe. Means whatever depth you have provided, that depth is safe for the deflection. Okay, now if it safe in deflection, so directly we can go for the detailing of reinforcement. See, this is detailing of reinforcement. So in both direction, means LX and in LY, both directions your diagram is same because we have provided the same reinforcement, 8 mm about 200 mm center to center. Okay, and alternate bent up bar that we have considered for the slab. Okay, in both directions. So this is plan view. Okay, alternate bent up bar in this direction, and in this direction also alternate bent up bar, and spacing between 2 bar is 200. Okay, so such type of detailing we can give to the site. Yes. So before proceeding for the singly reinforced beam, So if you have any doubt, that we will discuss, and then we will proceed for the next. Yes.
Hello.
Yes.
Hello.
Yes.
Sir,
Yes.
please go to the detailing of the section, that two-way slab section.
Detailing.
Section
Detailing.
detailing.
Yes. Huh. Hmm.
Yes, sir. Just a previous slide, sir. Previous slide. Section
Previous
one.
slide. Huh.
Yeah. Sir, in that we should not provide the distribution reinforcement in the top portion.
Distribution reinforcement at top here.
Yes, sir.
Here, na?
Yeah, yeah.
Yes.
Yes, sir.
Actually, it is not. Yes, you can say the distribution still, but actually it is extra reinforcement.
Okay,
You
okay.
can say distribution still, but it is extra reinforcement. Yes, we have to provide the extra reinforcement over here. But that reinforcement is nominal. Whatever extra reinforcement you are providing over there, that extra reinforcement is nominal reinforcement. Okay.
Okay, okay, sir. Because that
So
was
that is
missing, sir.
150
That's why I asked.
150
Edge strip
mm.
reinforcement could be at there.
Sorry.
Edge strip reinforcement.
Edge strip reinforcement.
Yeah.
Yes, actually in edge strip reinforcement also we are providing minimum reinforcement, required minimum reinforcement or nominal reinforcement. Hello.
Yeah. Yeah. Okay.
Yes. Because see, in one way slab also, correct, na? In one way slab also, distribution still we have considered as a minimum reinforcement or the nominal reinforcement, correct? So
Yes,
whatever
sir.
extra reinforcement is required at this position, that extra reinforcement is a nominal reinforcement. But now if you see over here, na, this detailing is only for the simply supported beam, but actually it should be like that. Okay. And then this reinforcement will continue like this. Are you getting?
Yes, sir.
Yes.
There should have to be mention that bent up distance and top reinforcement distance from the edges.
Bent up distance. Yes, yes, this distance, na?
Yeah.
Yes, yes, yes. We
From
have to
where we
mention
are
it.
bending. Yeah. We should have to
Yes,
mention at there.
yes, yes, correct. We have to mention because see, these values are different. If you see at the end, okay, at end support this value is different, and at continuous is also this value is different. So we have to
Yeah.
mention that bent up value. Yes, correct, definitely.
So it should be mentioned from the center of column or extreme end of the column
Actually, that
or
means
inner edge of
whatever
the column.
detailing is there. Yes, yes.
Hmm.
Whatever detailing is there, that detailing we can decide. I mean, structural engineer can decide. Okay, but only he should mention over there. Means whatever distance. Let's say suppose I have considered this distance as a L by 10. Okay, so that L by 10 is
But
distance.
from middle of the column or inner edge of the column or extreme edge of the column.
Extreme edge means which edge?
There is a possibility that is L by 10 you are seeing. So from the inner edge, yeah, exactly. From there or from the center of the column or from the extreme edge of the column. There are three possibilities. Yeah.
Correct.
Yeah. Exactly.
Okay. Yes. Actually, now, if you see, these distances are different, but IS code or I think SP16, SP34 also has given some guidelines regarding that. Okay. So as per this SP34, the if we consider L by 10, so that L by 10 is from the face of the column. Okay. But if you want to show that value from the center, so you have to add this value. Let's suppose this support is 230. So you have to consider L10 plus 230 by 2, like that. But basically, as per my point of view or as per my knowledge, basically that value we have to consider from the face of the column.
Okay.
Yes.
So that is the correct method of showing that bent distance.
Yes, from the face of the column. Because see, we cannot say it is correct method. That is choice of structural engineer.
Okay.
Okay, means basically what we have to focus, whatever drawing we are providing to the site, okay, that drawing should be read by the site engineer. Okay, that first we have to focus. Then we can give any means from the center or from the edge or from the face of the column. But I think means this method is okay, means from the face of the column.
Is it L by 7 or L by 10th? L by 10th should be at the topmost bar, and L by 7th should be at the bottom.
Now
Bentham?
I have taken it, it's just for example. L by 10 is just for
Okay.
example I have
Oh,
considered.
okay.
Okay, so it's L by 4, L by 6, L by 7, L by 10. Okay, so whatever actual value is there, that we will definitely discuss, because we have not covered any analysis, means any software, as well as design or the detailing also remaining na.
Hmm.
Yes, total that we will discuss, here I have taken only just for example.
Okay.
Hello.
Yes.
Yes, good evening, sir.
Okay.
Sir, one question is there. When we used to detail the slabs, when there are different panels which are in continuity of different sizes,
Hmm.
and support negative steel at the supports are different
Correct.
of both the slabs.
Barabar.
So, what is the ideal way of thinking of providing, means detailing those bars, alternate bars, or if there is less bar to provide extra bar, or what is means way to do that?
Okay, means while providing the reinforcement, correct
Yes,
na? While providing the
yes.
reinforcement at the support as well as at the mid span. So
Means at the sir, support we need to satisfy the condition of steel requirement at the particular panel, na?
correct,
Of
correct.
if it is a small panel, it will be different, and if it is a big panel, that is in continuation to the small panel, both two way.
Hmm.
So
Yes.
the joints, the negative movement that will be coming at the joints will be different. Means that will be different from
Hello.
both the sides. Hello.
Yes, yes. See, basically now, let's say suppose if any means, I think just first we will discuss your question. So maybe your question is like that. Means suppose if we consider any continuous slab. Okay. Correct. So let's say this is our S1 slab and this is S2 slab. Correct, na?
Yes, sir.
Yes. So how to provide the reinforcement at this edge, this
Yes,
support?
sir. Yes.
Correct. So see, generally, if you analyze it or if you calculate the bending moment at the different positions, so definitely bending moments are different. Correct. So let's say that I think we have discussed already, but okay. Let's say suppose bending moment at this position is 50 at mid span, and for this S2 slab is 70. Okay. Now suppose at this position we required 100 mm bending moment, and the required reinforcement, let's say at mid span for S1 slab we require 100 mm reinforcement. Now here let's say we required 150 reinforcement, and now here we require 200. Okay, 200 reinforcement. Let's suppose such type of reinforcement we require 100, 150, and 200. So if we use the bent up bar for this slab, so already 50% reinforcement we are providing over here. Correct. Alternate
Yes.
bar. So means at this edge from this slab already we have provided the 100 mm reinforcement. Sorry, 50 mm reinforcement, 15 mm square. Correct. Now again from this, okay, again some alternate bent up bars are coming from this side. and again 50% reinforcement we are providing over here, correct? And now if we see the 50%, so it is 75 mm, 75 mm square. So by due to the continuity, okay, for S1 and S2 slab, already we have provided the 125 mm square reinforcement over here at this edge, okay, 125 mm square reinforcement already we have provided, but our requirement is how much? 200. Let's say 200 requirement is there. So 200 minus 125, so it is near about 75 mm square, correct? So whatever 75 extra reinforcement is required over there, that extra reinforcement we are providing as an extra bar.
Okay, fine.
Like this.
Okay, okay. And sir, for sunken slabs, what is the ideal depth, means minimum depth we need to consider for residential projects?
See, ideal depth and minimum depth, that depth maybe is not given in IS code also. That depend on your material, means which type of material you are using for the particular slab, means or for the toilet or bath. So on that your depth is required, or depth we have to provide.
And sir, regarding the, if we don't know the weight of the filler material, then in how to take the conservative side, means what
No,
weight we need to consider for design of
means
of the
means
dead
means
load.
if yes, means if you don't have any material properties or material weight, correct na?
Yeah, we don't know what the filler material will be there.
No, actually that you should be confirmed from your architect or contractor.
Contractor, okay.
Yes. For the design purpose na, generally for the design purpose, don't consider any value or any load without consult your contractor.
Okay, okay, sir.
Yes.
And sir, one more thing about this slabs. What is the significance of this corners restrained or corners held down in design of the slabs?
Okay. Restraints and held down. So basically, restrained and held down, I think both are same. Restrained and unrestrained. These two conditions are there. Correct, na? Restraints means held down. Correct.
Yes.
Yes. So basically, restraint means what providing a lift of that particular corner. Okay. So to restrain this particular corner, we are providing the torsion reinforcement. Correct. Okay. And let's say basically it is not for the discontinuous, it is for the continuous edge. Okay. Here we have to provide the torsion reinforcement to prevent the uplift. Okay. But if we see the total area or the total area required for the torsion reinforcement, it's L by 4 and L by 2. So maximum is 50%. Okay. So maximum 50% reinforcement required to prevent the uplift of this corner. Okay. So if you see, generally we are providing the bent up bar in all the span, means we are not distributing this span as a middle strip and a strip, correct?
Yes.
Basically whatever torsion reinforcement is required, that torsion reinforcement we are providing only in the uh, edge, correct na?
Yes.
We are not providing it in middle strip, we are providing it as a edge strip, correct?
Yes.
So here we are providing the main reinforcement, means in field point of view, we are providing the main reinforcement in edge strip also. That's why we are not calculating this torsion reinforcement for the continuous span. Okay.
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 And sir, for checking the continuity of the slabs, we need to consider the shorter span of the slab for checking the continuity.
Checking the continuity means
short span continuity, or we need to check both long and short.
no
Means
for
the
the continuity.
means the slab, if we have a continuous different panels in a slab, so if we are checking the continuity, so we will check like the short span is continuous or the long span is continuous, or both
No,
the span we need to check?
both the slab we need to check because if you see uh yeah, if you see the clauses or cases, see in this case, okay, interior panel, one short is continuous, one long is discontinuous, two adjacent is discontinuous, two short edge, two long edges discontinuous, means both edges they are considering long as well as short.
Okay. Yes.
So we have to focus on both long as well as short span.
Okay, sir. Okay.
Yes.
Sir, if S1 is a two-way slab and S2 is one-way slab, such as 5 by 5 and 5 by 12. So,
Okay.
what about the edge continuity? Should we have to consider these cases which are considering for the two-way slab? That means continuity of edge we are discussing. Okay. So, beside of that, there is a one-way slab.
Mm-hmm. Okay.
So,
See,
we will consider that cases?
yes, but actually it's depend on your reinforcement, means direction of reinforcement. Let's say we will consider two span. Okay, this is our two-way slab,
Yeah.
and this is one-way slab. Okay, and another case also. This is our two-way slab, and now this is one-way slab.
Yeah.
Okay, now see in both case, if you see this one, let's say suppose first case and second case. So if you see in first case, actually direction of our main reinforcement for one-way slab like this. Okay, so it's vertical direction. Okay,
Hmm.
so this such type of slab we are not considering as a continuous slab. It is not continuous slab because direction of main reinforcement is different in one way and two-way slab. But if you see second case, in second case, direction of main reinforcement is what we can say continuous to the two-way slab. So now this is we can consider as a continuous.
Okay.
Yes.
Okay, sir. Thank you.
Yes. Yes. Okay. So shall I proceed for beam?
Sir, one more question I am having. Sorry for
Yes.
that.
Yes. Yes. Yes.
Sir, whatever design we have been considered just now. So, for the structural auditing type, if by means any structure gets failed and we are showing this design, so is it sufficient to that? Or we will have to consider cracking weight or thermal cracks and shrinkage and so and so?
No, actually, for the auditing point of view, so first we have to focus the basic design of that uh, element. Okay, whatever slab or beam is there. So first we have to focus on that. Okay, so whatever
Mhm.
cracks are there or whatever what we can say the
Because
uh,
whenever the
defects are
structure
there.
gets failed, then structure audit will check all the things, all the
Yes, is
aspects. So that's why it should be satisfactory while showing the design. So that's why I'm having that question.
yes, yes, correct, correct. Actually, now, what happened means suppose if you want to do the structural audit for the element, any element. Okay, so first we have to focus on the behavior. Behavior means the total defects on that particular element that we have to focus. Okay, and before that we have to focus on the design also. Okay, means let's say suppose if I focusing on that particular slab. Okay, just wait. Okay, let's say suppose I have considered this slab and so many cracks are there, deflection is there, okay, in that particular slab. So first what we have to focus, whatever reinforcement or whatever depth is provided, okay, Are you getting? Whatever reinforcement or depth is provided in that particular slab, that reinforcement or depth is sufficient or not. Okay, that thing first we have to do, because see, some defects are there or some deflection is there, some cracks are there. Definitely it's due to the maybe design, or it's maybe due to the poor material that used in that particular slab. Correct. So maybe
Yeah,
these
but
things are
they
there.
will check first the design. They will check first the
Yes.
design.
Yes, correct. So first we have to check the design. Okay, and for that design, first we have to design all this slab manually. Okay, just do the manual design, or you can design it by the Excel, or you can design it by the RCDC, that software that we will discuss. Okay, definitely. Okay, that is in our programming. So after that ETAB, we will see the design of slab or the design of element by the Excel sheet, then RCDC that we will use. So first we have to design it, and then check your reinforcement with the existing reinforcement, and then decide, or depth also, then decide actually what defects are there. Maybe some defects are in concrete also. Correct. So whatever concrete are required at that site, maybe suppose M20 grade of concrete is required and they have provided M10, okay, or M15, so that concrete is not sufficient. That we have to do in the structural auditing. So yes, if you have joined for the master course, okay, so in master course, second, I think second sector is auditing. After the first course, HRB means high rise building. Second course is the auditing course, and in auditing sector, all these things again we will discuss. Means how to design that beam elements, and then how to consider the defects. Means whether reinforcement is not sufficient, whether depth is not sufficient, whether concrete is not sufficient. That definitely again we will discuss in auditing.
Yeah. Because many, I think I do have one case at the Mauda where the slab gets filled. So at that time, there are design has been checked. So that's why I'm having that question.
Yes. Definitely. First thing we have to decide. First, we have to focus on the design.
Yeah.
Maybe if deflection is there or the cracks are there, so maybe reinforcement is not provided sufficiently. Maybe, not. We cannot be blame on the reinforcement only. Okay. So some
Because
concrete.
at that time only report will say what exactly there is. Yeah, that's
Correct.
why I'm.
Correct.
Okay, sir. Thank you.
Okay. Okay. So now we'll continue with this singly reinforced section. So again, see, basically theoretical point of view, two types of beams are there as per the reinforcement: a singly reinforced section and doubly reinforced section. And if you see the actual meaning of singly reinforced section and doubly reinforced section, theoretical point of view. So singly reinforced section means reinforcement in only one direction. Sorry, reinforcement in only one side. Okay. If you suppose, let's say suppose this is cross section of our beam. So in cross section of beam, this is our tension side, and this is compression side. If you consider the rectangular simply supported beam, it's applicable only for the rectangular simply supported. I'm discussing about rectangular simply supported beam. So this is our tension side. Bottom is the below the neutral axis tension side, and above the neutral axis is the compression side. Okay. So singly reinforced section means we have to provide the reinforcement on tension side only. Means reinforcement is on only one side. That is singly reinforced section. And doubly reinforced section means reinforcement is on both sides, compression as well as tension. Okay. Okay, so that is a theoretical difference between singly reinforced section and doubly reinforced section. But if you see the field point of view, okay, so in beam generally we are providing stirrups also. Correct? We are providing stirrups also. So to hold that particular stirrups, we have to provide some nominal reinforcement at top. Okay, to hold the stirrups, I repeat, to hold the stirrups, we have to provide some reinforcement at the top, whether that particular beam as a singly reinforced section. Okay, so if you see in field, so generally we are providing the doubly reinforced section. Okay, but as field point of view also, difference between singly and doubly reinforced section is what? In singly reinforced section we are providing the nominal reinforcement at top, and in doubly reinforced section we are providing the design reinforcement at top. That is the main difference. Are you getting? Yes, that is the main difference. Means if any reinforcement is required in compression side, okay, design reinforcement is required on compression side, that particular beam is called as a doubly reinforced section. And if you are providing the nominal reinforcement at top, that particular reinforcement is called as a singly reinforced section, or the section is called as a singly reinforced section. That is first thing. Second thing, where we have to provide the singly reinforced section and doubly reinforced section. So basically, so many criteria are there to provide the singly reinforced section and doubly reinforced section. But I will focus, or I will try to focus on some points. So first point, for this doubly reinforced section, why doubly reinforced section is required? Okay. So first is there is, if there is any restriction in the depth, okay, if depth restriction is there, because see, in design we will discuss, so how singly reinforced section and doubly reinforced sections we have to decide, means whether singly reinforced section is required or doubly reinforced section is required, that we will discuss. But first criteria is if any restriction in depth, okay, so in that case we have to provide the doubly reinforced section. Okay, doubly reinforced section if restriction in depth. Okay, that is one thing. Second thing, generally if longer span is there, okay, long span is there, so for long span also, to avoid the deflection, okay, we have to provide the doubly reinforced section. Okay, so as per the design point of view, or as per my knowledge, these 2 points are most important to decide the doubly reinforced section. Okay, yes, if any discussion with the singly and doubly reinforced section, I'm not saying the queries, it's just discussion. Okay, yes, any other discussion on the singly and doubly reinforced sections that we can do? Yes, any queries or discussion, singly or doubly? Yes, is that clear?
Yes, sir.
Yes. Now we'll proceed for the next, how to design any beam. Okay, so again, if you compare the slab design and the beam design, basically slab design and beam design is same. How? First calculate the, just I am saying design point of view. First, in both slab as well as or in element, first aim is what? To calculate the reinforcement. Okay, so for AST we require bending moment, for bending moment we require loading. Okay, now the loading is different in beam and slab. Generally in slab we have considered the dead load, live load, and SIDL, that is additional load. Okay, so dead load is from the self-weight. Dead load here we have calculated as a self-weight. Live load, that is different. And SIDL, now this SIDL we have considered additional dead load that we have considered in slab. I am discussing about the slab. That additional dead load we have considered only the material, only for the material, means whatever material we are providing for that slab, that load we have considered over here. But now in beam, in additional dead load or superimposed dead load, some dead loads are there. That is, in that dead load, first is load coming from slab. First is load from slab, that we have to consider. And second thing is load of wall. Okay, so for the design of beam we have to focus on these two load while calculating SIDL, super dead load or superimposed dead load. Okay, so this difference is there for the calculation of dead load, and all other thing is same. Okay, that is one thing. Second thing, in check, generally in check for slab we have taken only the deflection check, we have considered only the deflection check. But in beam we have to consider deflection check as well as the shear check. Deflection check as well as the shear check, because some shear force are developed. Okay, and for the shear whatever shear force is developed over there, to resist that particular shear force we have to provide the shear reinforcement. Okay, that is one thing. So whatever shear check is there, means whatever reinforcement are there, so in that reinforcement we are providing two types of reinforcement. First is the main reinforcement, and second is the stirrups or the shear reinforcement. Okay, so whether that shear reinforcement is required or not required, that we can consider from this shear check. Okay, and same shear check we can consider in slab also. Okay, generally in slab we have not taken shear check, but if you interested to check the shear in slab, yes, definitely you can do it. Okay, but difference is what? Let's say suppose shear reinforcement is not required. Okay, I am discussing in both slab as well as beam. If shear reinforcement is not required, so generally in slab we are not providing that shear reinforcement. Shear reinforcement means stirrups. Okay, shear reinforcement is stirrups. So in slab generally if shear reinforcement is not required, so we are not providing the stirrups. But in beam, if shear reinforcement is not required, in that case also we are providing the shear reinforcement, nominal shear reinforcement we are providing. So why we are considering that nominal shear reinforcement? Okay, because here shear reinforcement is not required. Okay, in that condition also we are providing the nominal reinforcement, because shear reinforcement is required in beam to hold the stirrups. Already we have discussed it. Okay, to hold the stirrups, nominal shear reinforcements we have to provide. Okay, so to calculate the shear reinforcement, so many parameters are there. Okay, sometimes let's say suppose this is our beam, and if you see the behavior or the shear force of this, let's say suppose this is simply supported beam, and if you consider the shear force of this simply supported beam, correct? So this is our shear force. So some structural engineers are divide this beam in two parts or two zone. Okay, let's say this is our first zone, and second zone. This is also first zone. Okay, so some structural engineer are divide this total beam in two zone only, and some structural engineer are divide this beam in three zone. Okay, first, second, third. Here also third, second, and first, like this. So it's depend on you, means if you want to optimum design, okay, for the shear reinforcement, so you can divide in three part. So if you want to less optimization, so in that case divide in two parts. And if you are interested to provide the design reinforcement throughout the beam, yes, no problem, you can provide throughout the beam as a design reinforcement also. Okay, so see, if we consider the three zone, basically this last zone having the maximum shear force, so here we are considering the design shear force. Okay, at this position we are considering the nominal reinforcement, nominal shear reinforcement, and at this we are considering the minimum reinforcement. Okay, so design, nominal, and minimum, if you provide or if you consider three zones for the shear reinforcement. Okay, and if you are consider only two, so in that case we are considering design and nominal. Okay, we are not going for the minimum. Okay, so such criteria is there. So as per your convenient or as per your style, you can calculate the shear reinforcement. Okay, so I think this is main point that we have to consider before designing of any beam. If any point is remaining, that you can discuss, no problem. Yes. Okay. So while considering the additional
Hello?
dead load that we have yes.
Sir, how to fix that zone?
How to fix
Hello?
that zone? How to fix that zone?
Zone. Yes, sir. Because in the support section, the shear force will be more. So that's why we need to provide the shear reinforcement in closer distance. At the mid span, you have to go for some more distance, and that one clause is given, I think, in the SP34. So we have to follow that, or
yes. Basically, see, by considering this zone, here we have considered three zones or 3 points, that is design, nominal, and minimum. Correct. So for the design, we have the different one. Let's say suppose in IS 456 also and in SP34 also, some formulas are given as per the zone. That formula is in LD and spacing. So LD equals to such formula is there, that is 0.87 FI sometimes, and spacing. Correct. So such type of formula is
Hello,
there
sir.
for the design.
Hello.
Yeah. Yes.
So what is the difference between minimum reinforcement and nominal reinforcement?
Actually, as per the IS code, they have given the different formula to calculate the nominal and minimum. Different formulas
Sir, I
are
think
there.
nominal as the minimum. Sir, I think nominal as well as the minimum both are same,
Yes.
sir.
Yes, actually, as per the meaning or as per the slab point of view, nominal is equals to minimum. Correct. But in beam point of view, generally in slab, in particularly beam, they have given the nominal reinforcement is different and minimum reinforcement is different. Okay. Okay. So this formula is there to calculate spacing as well as the length. Okay. Let's say suppose this is our beam, and if we consider only two zone, okay, 2 1 and 1 2 1 like this. Okay, if you consider this, so whatever length is there, means how to consider this length, correct? Now that is the question, na? How to consider this one? This length of zone. Okay, so this formula is given in IS code. So from this formula we can calculate this LD means this length as per the spacing, and if you have the spacing, so as per that spacing we can consider LD, or if you have LD, so as per that LD you can calculate the spacing. That we will discuss. Okay. Okay. So this is our criteria design of singly reinforced of first floor G plus, means first, this is our first floor. Okay, let's suppose this is our first floor and we are considering this beam. Okay, B6, and that B6 having two slab, that is S1 and S2. So S1 is two-way slab and S2 is one-way slab. Okay, so load transfer is different for two-way and one-way slab, that we will see. So these are the given our assumptions: grade of concrete, grade of steel, clear cover, length of beam, unit weight of concrete, then slab dimension. S1 is 2660 by 2890 and S2 is 940 by 2660. Okay, floor to floor height is 3 meter. Now in floor to floor height we have not deduct depth. Okay, because in calculation of wall, means height of wall, that depth is most important, or the floor to floor height is most important. But now here we are designing the beam, so we don't have the depth of beam, so that's why we have considered the total height, floor to floor total height, that we have considered over here. Okay, trial dimension of the beam. Okay, so first assume the width of beam is 230. It's just trial dimension. So first we have assume here width of beam, then effective depth. This is a standard formula which is given in SP 34, L by 10 to L by 15. Okay, so consider length is 2660. Here I think we have considered it 2660 beam length. Okay, so 2660 by 10 to 2660 by 15, so it's 266 and it is 177. Okay, so now as per the depth, we can provide depth as a 266 or 177, but we are going for the higher side. Now this 266 we have rounded up by the 300. Okay, so now this depth we will consider. So now for this beam, our dimensions are 230 by 300. Okay, now assume the diameter and the clear cover. So 12 mm diameter and 25 mm clear cover. Calculate overall depth. So overall depth is 331. Now again we have round up it up the 375. Okay, you can assume 350 also, no problem. You can use 350 also. Okay, So 350 also you can consider, but now here we have considered 375, and if you consider 375, so our effective depth is 344 mm. Okay, so now final effective depth is 344, overall depth is 375, and width is 230. These are the dimensions. Now just wait. Now next effective span, same criteria is there. L plus D, D means bearing, okay, and L plus D, D means depth, okay. Here we can consider bearing, this one. And if you are not interested in this, so you can neglect it also, because basically that bearings come only for the slab. Okay, actually this formula is given in IS code, but that bearing you can consider only for the slab, because for beam generally bearing is not there. So you can go with this effective depth also, 2660 plus 344, so 3004. So we can consider this length 3L equals to 3004, and we should be considered it 3004. Okay. So load calculation, that is important. Superimposed dead load. So superimposed dead load means additional dead load coming on our beam. So first wall load, okay. So wall thickness into floor to floor height into unit weight of brick, okay. So now wall thickness is 0.15, floor to floor height 3 meter, and unit weight of brick is 20. So 0.15 into 3 into 20, that is 9 kilonewton per meter. And most important thing is no deductions of depth of beam is made from floor to floor height, because here we have considered 3 meter height of wall, but if you deduct the depth, let's say suppose our depth is 344, okay, or overall depth 375, okay. So this height should be 3000 minus 374, so actually it is 2525, correct na, 2525, okay. So this depth or this height should be there, but now here we have not deduct this depth, okay. We have considered the total floor to floor height.
Yes, sir.
And we have mentioned over there. Okay. Now next is the slab load transferring on beam. Okay. So if you see, this is our beam that we are designing. This is our two-way slab, correct? I think these are one-way slab. I think trapezoidal loading is there. Just we will cross check it. Yes, it is different. Just better. It is like that. Okay. Okay. Now S2 slab. This is our S2 slab and S1. So S2 slab means load transfer from S2 slab to this beam. S2 slab to beam. So first, sulphate of slab. Okay. So dead load, that is depth into unit weight of concrete 0.125 into 25. So that is 3.125 kilonewton meter square. That is sulphate of slab. Okay. Then live load, that live load is also coming on slab. That is 2 kilonewton per meter square. Then superimposed dead load on slab. Okay. So it's floor finish. So sulphate, flooring, and sunk slab. Okay. So if toilet is there, then and then this sunk slab will come over there. But now here, I think sunk slab they have considered. S2 slab. Sorry, this is our S2 slab. This toilet is there, so for toilet we have to consider the some slab also. Okay, this is our S1 and S2 slab. Okay. Okay. So some slab is there that already load we have calculated for the design of this particular slab. So at total load is 13.125 kilonewton meter square. So this S2 load is on the slab, S2 slab only. Okay. And if you see this slab, the one-way slab, and our reinforcement we are providing like this. So half of the reinforcement, half of the loading will transfer from this slab to the beam. Okay. So triangular load of slab S1 is transferring on the beam B6 as S1 slab is two-way slab. Actually, some corrections are there. Triangular it is rectangular. It should be rectangular. Huh? Rectangular load is transfer from S2 slab to B6 beam as S2 slab is a one-way slab. Some corrections are there. Huh? As one-way slab. No, actually it's totally different. Corrections are there because they have considered the triangular load S2 slab, S1 slab that we will see. Yes, this formula should be there. WLX by 2. Correct.
Yes, sir.
Yes, this formula should be there. WLX by 2. Okay, and this WLX by 3. This formula is for S2 slab, S1 slab. That is confusion. Okay, so just wait. Is this clear?
Yes, sir.
It should be 2.
This is for one-way slab.
Yes, this is one-way slab. So S2 and S2 one-way slab, and that one-way slab means load is transferred that LX by 2. Correct. So total load on slab is 13.125. Span is 2.66. This span is also 3 point something. 3.004. Right? Just wait. I'll calculate it. So 13.125 into 3.004 divided by 2. So it is 19.71 kilonewton per meter. Okay, that is this 19.71 load is coming from S2 slab to beam. S2 slab to beam. Okay. Then next S1. Now S1 is two-way slab. Okay. Now this triangular load is WLX by 3. Okay. And trapezoidal load means if you see two-way slab, for the shorter span it is triangular load, and for longer span
Trapezoidal
load. For longer span it is trapezoidal load. Let's say this is our LX shorter span and this is LY longer span. Okay, so such type of loading is transferred over there. Now here we have considered beam at this position. So triangular load will transfer from slab to beam.
WLX by 3.
Okay, and this formula is WL by 3.
WLX by 3, yes.
Okay, WLX by 3. So that formula here we have considered WLX by 3. Again same, calculate sulphate, live load, and then super dead load. Now in this super dead load, this is our S1 slab, and now here we have not considered any sunk load because this is the general slab. Okay, so consider all load, and then load transfer from S1 to beam is 8.81. Okay, so it's 8.81. So just wait, I will calculate it. 2.004. So 6.625 into 3.004 divided by 3, it's 6.63. 6.63. Now this is 6.63. Okay, now total load transfer from S1 and S2 slab. Now from S1 slab, S2 slab, sorry, 19.71. This one 19.71, 19.71, and this 6.61. So 6.63 plus 19.71, it is 26.34. 26.34 kilonewton per meter. So this is total load 26.34. That is total load coming from slab to beam. Okay. Now next one is sulphate of beam. Okay. B into D, overall depth into density of concrete, and live load should be there. Live load, I think live load we have considered. Super dead load, wall load, that is 9 kilonewton per meter, correct? 9 kilonewton per meter is super dead load. Then in second we have considered load transfer from the slab, and in third sulphate of beam. Okay, super dead load, load transferring from beam, and the sulphate. So total load of beam is 31.60. Okay, so convert in, I think that we have to modify it. This one is 26.34. 26.34. So 26.34 plus 9 plus 2.156. 37.48. 37.48 multiply by 2, 31.5. It's 56.29. Okay, so this is our total ultimate load or factor load. And then bending moment, again WL square by 8, and another procedure is same, that we will discuss tomorrow, one way and two way slab, because some corrections are there. That corrections I will do today, and then we will discuss in next session. Okay, because the bending moments are different, because here they have considered only 47. Okay, load is 47, but actual load is 56, correct? So that corrections I will do, and then we will discuss it. Okay, actually most important thing is to consider shear reinforcement, whether that shear reinforcement is required or not. That is most important. And then deflection check, that we will see. Okay, so that we will see on tomorrow. But yes, before that, if any doubt, so that we will discuss, because 9 is also there. Single reinforced beam and double reinforced beam, that we will discuss tomorrow. Yes, in next section. Yes.
Okay, sir. Okay, sir.
Sir, one small doubt is there.
Yes.
Sir, when we are designing the secondary beams, and in Stat Pro, if we are releasing the bending moment in Z direction to release the torsion, so in the site, in practical condition, is it good? Is it better practice to not provide L L length at that point, or simply put the straight bar over the main bar? What should be the process of detailing it?
Detailing of reinforcement. Correct.
Yes.
To join secondary beam to the main beam.
Yes.
Correct. See, actually, that we will discuss in detailing, but just for curiosity, I will explain it in short. But detail we will discuss. See, if you consider, let's say suppose first we will see this beam. This is, let's say suppose this is our beam. Correct. And first we will consider both ends are fixed ends. This end is also fixed, and this end is also fixed. Okay, so to maintain this fixity, what we have to do, we have to provide we have to provide the reinforcement or the anchor reinforcement in this beam, correct, like this.
Yes.
Then and then your fixity is maintained, correct na?
Yes.
Yes. So actually, what is the work of this anchor bar? Let's say suppose I have considered anchor bar from this position to this. Okay. So what is the work to maintain
To
the fixity?
transfer the bending moments,
Correct. To transfer the bending moment from beam to column.
columns. Yes.
Okay. But if I consider, suppose if I want to consider that beam as a simply supported beam, so what we have to do in simply supported beam? Generally, we don't want to distribute moment from span to the
Top means to the support.
okay. So for that case, we have to consider the reinforcement only at the only near or only up to the face of your column, like this. Such type of reinforcement should be there. Okay. So
Okay.
due to that reinforcement, so this bending moment will be there.
Okay.
Like okay. But if you provide such type of reinforcement, so
Deal with
so
torsion.
in this case, bending moment is not there. So in this case, your bending moment is like this.
Yes.
Okay.
Mhm.
So definitely we will discuss it in detail.
Okay. So sir, right ways to the drawing you have drawn the below is it is the right method to if we are releasing the moment in means in stat, so we will be detailing like that. The one you
Yes,
have drawn below it, huh?
correct. This one is correct.
Okay.
Yes.
Because sir, many times I have seen because we are also preparing the drawing. So many times we have seen that sometimes in the site, even if in the software means while designing the building we are using releases, but in the site actually there is L provided at that particular point.
Yes. Generally, inside also we are providing L there.
So it is wrong, na sir?
Conceptually, it is wrong, but on site they are providing.
Okay.
Yes.
Okay.
One more important thing in slab. Okay, one more important thing. Okay, let's say suppose if you consider in slab, so in slab generally we are providing bent up bar, correct? Alternate bent up bar.
Yes, sir.
But at the time of casting, so many workers are there. So whatever concept that we have used means you are this bent up bar or whatever bent that we have provided, that bent should be at the top, correct? But
Yes.
at the time of casting, if you see that reinforcement is not at top. Have you फोकस किया आपने वो समझ में आ रहा मैं क्या बोलना चाहता हूँ जनरली हम बेंट अप बार जो प्रोवाइड करते हैं ना यहाँ पे इसका मतलब क्या है कि ये जो भी बेंट प्रोवाइड कर रहे हैं ये टॉप में आना चाहिए बराबर है
Yes, sir.
लेकिन जो भी वहां पे वर्कर वर्क करते हैं ना सो वो वर्क करते समय या जो ट्रॉली है वो ट्रॉली घुमाते समय जो भी वहां पे मूवमेंट होती है वो मूवमेंट थ्रू वो बार जो है वो बार टॉप में नहीं रहता वो पूरा लेट जाता है
बैठ जाता है। यस
बैठ जाता है वो पूरा बराबर है
उसके लिए चेयर लगा देते हैं सर कई बार चेयर।
वही तो वो प्रिकॉशन एज अ साइट इंजीनियर वो प्रिकॉशन हमें लेना है
yes.
तो जनरली साइट इंजीनियर उसके ऊपर फोकस नहीं करते ये मुझे बताना था एक्चुअली
ओके सर।
तो ये भी ये जो भी फॉल्टी होता है वहां फॉल्ट होता है जो भी वहां पे रहते हैं ये करेक्शंस बेसिकली हमने देखना चाहिए एज अ साइट इंजीनियर और स्ट्रक्चरल इंजीनियर आल्सो ऑब्वियसली वी हैव टू फोकस ऑन दैट तो ऐसे भी थोड़े थोड़े मिस्टेक्स होते हैं और ये डिजाइन करते समय ना आपने जो बोला अभी ये डिजाइन करते समय ना आरसीडीसी में वैसे ऑप्शंस भी है कि जो हम मेन बीम डिजाइन कर रहे अगर मेन बीम को सेकेंडरी बीम आपका ज्वाइन हो रहा है और मेन बीम डिजाइन कर रहे तो आपको कितने अमाउंट में टॉर्शन रेनफोर्समेंट नेग्लेक्ट करना है उसका भी हम रेनफोर्समेंट देते हैं और उसके लिए क्या प्रोविजन है लेट से सपोज हमने एक्सटेंशन बढ़ा भी दिया ओके सिंपली सपोर्टेड बीम का बार हमने एंकर करके मेन बीम में डाल दिया, तो उसके लिए क्या प्रोविजन कर सकते हैं एडिशनल? आपके पास कुछ सॉल्यूशन है साइट पे, ऑन साइट क्या करते हैं उसके लिए? फिर क्या करना चाहिए,
नहीं
क्या
सर,
लगता है
सॉल्यूशन तो नहीं
आपको?
है।
क्या लगता है क्या करना चाहिए? अगर ठीक है टॉर्शन रेनफोर्समेंट आ रहा है वहां पे, तो क्या करते हैं टॉर्शन रेनफोर्समेंट के लिए? जनरली एज a structural point of view we are neglecting the torsion reinforcement on any element। कौन से भी एलिमेंट पे हम टॉर्शन रेनफोर्समेंट नहीं आना चाहिए ऐसे ही डिजाइन करते, नहीं आना चाहिए।
उसको टॉर्शन के लिए
बट
डिजाइन
फिर
करना
भी आ
पड़ेगा
रहा
सर फिर उसमें।
है। यस,
तो या तो सर फिर उसे टॉर्शन के लिए डिजाइन करें, फिर हम टॉर्शन कमांड वो लगा के उसमें
यस टॉर्शन
बीम
के लिए
को।
डिजाइन करना चाहिए, ठीक है। टॉर्शन कमांड यूज करने के बाद जो भी रेनफोर्समेंट देगा वो सॉफ्टवेयर देगा, बराबर है। बट जो रेनफोर्समेंट सॉफ्टवेयर से हमें मिला है उसको क्रॉस चेक करना पड़ेगा
जी जी जी।
कि भाई उसने रेनफोर्समेंट दिया है, बट वेदर दैट रेनफोर्समेंट इज ओके और नॉट। यानी कि मुझे जो लगना चाहिए मेरे दिमाग में कि टॉर्शन रेनफोर्समेंट अगर है, टॉर्शन वहां पे आ रहा है तो उसका रेनफोर्समेंट ऐसा ही रहना चाहिए, करेक्ट। अगर वैसे सॉफ्टवेयर ने नहीं दिया और गलती से हमने वो प्रोविजन नहीं दिया, सो वी शुड बी क्रॉस चेक इट ना मैन्युअली
ये
और एज
ये
पर आवर नॉलेज। सो उसके लिए क्या प्रोविजन है, ये मेरा क्वेश्चन है एक्चुअली।
सर उसका तो पता नहीं है सर, आइडिया नहीं है।
ओके ओके, उसके लिए जनरली साइड फेस रेनफोर्समेंट भी रहता है।
अच्छा, टॉर्शन का, जी ओके।
और हाँ, साइड फेस रेनफोर्समेंट भी रहता है। अगर टॉर्शन वहां पे आ रहा है तो साइड फेस
जी जी जी।
रेनफोर्समेंट रहता है। सो इसलिए अगर आपने बीम आरसीडीसी में डिजाइन किया, मैन्युअली किया, एक्सेल सीट की मैं बात नहीं कर रहा हूँ, आरसीडीसी में अगर आपने डिजाइन किया तो आरसीडीसी में कुछ बीम के साइड फेस रेनफोर्समेंट भी आते हैं।
जी
यस, तो वही
ओके
थोड़ा बहुत टॉर्शन वहां पे है इसलिए वो होता है वैसे जनरली।
ओके ओके
ओके ओके।
ओके, थैंक यू वेरी मच सर।
हेलो सर।
यस।
सर बोल रहे हैं अभी जो आप ऊपर वाला फिगर ड्रॉ किए हैं सर, वो बीम
हम्म
में सपोज मान लीजिए जो कॉर्नर में आप दिखाए हैं जहाँ पे अभी आपका क्रॉसर है, जो
हम्म
एल हम लोग कॉलम के अंदर,
हम्म
अगर मान लीजिए कोई साइट में नया बार बेंडर या फिटर फोरमैन आया, उसको एल को काट दिया, तो उसके
हाँ,
लिए सर क्या सोल्यूशन रहेगा?
एल को काट दिया यानी कि ये एल प्रोवाइड ही नहीं किया।
बिल्कुल एल काट दिया, बिल्कुल कॉलम का सेंटर में ले जाके स्ट्रेट बार दिया, एल नहीं करके बिल्कुल स्ट्रेट बार दिया, बस बस ऐसा ही सर।
ओके, उसके लिए प्रोविजन
सर उसके लिए कुछ क्या प्रोविजन और कर सकते हैं हम लोग, मान लो?
नहीं, एक्चुअली उसके लिए प्रोविजन तो एक तो मुझे भी देखना पड़ेगा क्या है। तो एक्चुअली ऐसा तो होता नहीं जनरली, क्योंकि जो भी स्ट्रक्चरल इंजीनियर है, यानी कि
सर
जनरली कैसा रहता है कि एक बार आपने पूरा ये कर लिया, टोटल बार आपने बाइंडिंग कर लिया, जब
सर
स्ट्रक्चरल इंजीनियर वो क्रॉस चेक करेगा तभी
सर
फाइनल होता है, बराबर है। So, अगर ऐसी केस आई तो जनरली एज पर माय नॉलेज तो टोटल बार रिप्लेस करना पड़ेगा ऐसा मुझे लगता है। बट यस, दूसरी कोई प्रोविजन हो है तो मुझे वो देखना पड़ेगा थोड़ा।
ठीक है सर। और एक चीज है सर, ये सिंगल जो सर टॉप बार है, उसको मतलब हम लोग अगर स्क्रैप यूज करना चाहें तो उसको लैब देके कर सकते हैं क्या सर?
इसको लैब देके ऐसा ऐसा ना?
जी सर, ऐसे।
हाँ, लैब देके यस, एडिशनल बार आपको प्रोवाइड करना है तो लैब करके आप कर सकते हैं। हाँ, ये सोल्यूशन हो सकता है, करेक्ट, हो सकता है ये सोल्यूशन, लैब
कैन
प्रोवाइड
वी
करके आप कर सकते हैं।
वेल्ड वेल्ड भी करके कर सकते ना सर इसको?
वेल्ड जनरली हम नहीं करते यूज इसमें, कि अगर आपने देखा ना कैपेसिटी जो टेंसाइल कैपेसिटी बोलो या फिर लोड कैरिंग कैपेसिटी बोलो, वेल्ड
जैसा
की
अभी
थोड़ी कम है।
यल शेप में जैसा अभी लैपिंग कर रहे थे, तो
हम्म,
इंस्टेड ऑफ लैपिंग वी कैन जस्ट वेल्ड इट।
यस यस, बट एक्चुअली ना एज पर माय नॉलेज जो भी वेल्ड की कैपेसिटी, दैट कैपेसिटी इज लेस एज कंपेयर टू द लैब।
ओके ओके।
Hello.
अगर हाँ यस
May I add some points, sir?
यस नो प्रॉब्लम सर, इसीलिए तो मैं डिस्कशन बोलता हूँ, डिस्कशन।
Actually, yes, sir. Actually, in IS 456, it is mentioned that if the diameter of the bar is going 32 mm, then we can go for weld, or else we have to provide anyhow lapping.
Yes, okay.
And another thing, sir, if you want to provide the lapping at that column and beam junction, it is very much difficult for the mason or the who is bending the bar.
Okay.
Execution of the all these things in site is very much difficult, sir.
Right.
सर वो जंक्शन में जाके
Sir,
क्रिटिकल हो जाता है जाके, क्योंकि एग्रीगेट साइज जो है वो अंदर नहीं घुसेगा बराबर, क्रिटिकल हो जाता है, मतलब हनीकॉम्ब स्ट्रक्चर आता है।
लैपिंग अगर हमने दिया तो करेक्ट,
हाँ, बराबर वाइब्रेशन नहीं होता है।
Sir, another thing, sir, that whatever the anchorage length we are providing, that is coming around, it will be 45D or 40D or 550D. But that much space is also not there. That much space is also not there. We cannot provide the beam reinforcement into the column. So generally, we are not providing that much of actually.
Okay, म्हणजे conclusion is what lap length is not sufficient. Lap length we cannot be considered as a lap over there. Correct ना?
Yes, sir.
सर
Yes.
इसमें सर इसका
how
जो
much you are providing
लोकेशन
the anchorage length, sir? Hello.
हाँ
Sir, how much length you are providing that as anchorage length or that L? How much length you are generally providing, sir, in site or
this
in
one,
design?
this year
That
ना?
L, yes, sir, yes, sir.
That is development length, LD.
Yes, sir. LD, that is we have calculated that formula, that 0.87, that formula wise, or anything that we are providing that
Actually
based on some experience.
formula is given na in IS 456. What formula is given?
Yes, sir. Formula
in
is
the form
given.
of tau
Okay.
by bonding strength.
Yes, sir. Yes, sir. I know that formula.
Yes.
Yes, sir.
So generally that formula we are using. Okay. Okay, so we will wait for 1 minute. If you have any further discussion, so we can continue. See, इसको मैं डिस्कशन इसलिए बोलता हूँ कि कैसा रहता है कि जो भी आपके क्वेश्चंस है कि सभी के क्वेश्चंस के आंसर मेरे पास हो गया, ऐसा कुछ नहीं है। सो अभी भी जैसे देखा जाए तो जो भी स्ट्रक्चरल इंजीनियर बोले क्यों और नॉलेज बोले, सो जितना भी लिए उतना कम ही है। सो अभी भी मैं कहता हूँ कि जितना भी मुझे नॉलेज है, आई हैव ओनली 20 to 30% नॉलेज इन स्ट्रक्चरल इंजीनियरिंग. So many parameters or so many concepts are again we have to, or I have to generally.
सर
Yes.
सर बोला था ये एक फ्रेम स्ट्रक्चर बिल्डिंग में सर हम लोग एज कलम को फिक्स सपोर्ट लेंगे या मिडिल कलम को भी फिक्स सपोर्ट ले सकते हैं?
कॉलम को फिक्स सपोर्ट या मिडल कॉलम को फिक्स सपोर्ट?
जी सर.
जनरली फ्रेम में देखा जाए ना तो
सर
फ्रेम हर एक जंक्शन आपका फिक्स ही रहता है.
हर एक जंक्शन को फिक्स सपोर्ट ले सकते हैं ना सर?
फिक्स ही रहता है.
तो हम लोग सर आप जो ये बॉटम वाला बीम का सेक्शन ड्रॉ किए हैं, ऐसे वाला दे सकते हैं कि ऊपर वाला जो सेक्शन दिए अभी जो एल करके
ऊपर वाला.
दे?
बॉटम वाला कब आएगा? जब आपका सेकेंडरी बीम मेन बीम को कनेक्ट हो रहा है.
अच्छा सर, ठीक है सर.
तभी आएगा.
सर हम तो अभी भी हमारा साइट में सेकेंडरी बीम जो है हमारा प्राइमरी बीम के ऊपर जो रेस्ट कर रहा है उसको भी तो हम ऐसे ले जाके ऊपर में बॉक्स करते हैं, प्राइमरी बीम के ऊपर बॉक्स के क्लोज करते हैं.
ये ऐसा फोल्ड किया होगा.
हाँ सर.
जनरली नॉमिनल वहां पे प्रोवाइड करते हैं. नॉमिनल जो है ना यल वहां पे प्रोवाइड करते हैं, बट इट्स नॉट अ डिजाइन एलडी. डिजाइन.
हाँ ओके सर. दिस इज नॉमिनल. ओके सर मतलब वो उसको खाली एंकरेज के लिए बस, और कुछ नहीं है ना सर?
बस 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 एंकरेज।
ओके ओके ओके।
तो उससे जनरली टॉर्शन मोमेंट वहां पे क्रिएट नहीं होना चाहिए, बस इतना केयर लेना है हमें।
ठीक है सर।
Okay, so today we will stop here. In next sessions we will continue for one way with correction, sorry, single reinforced section with correction and double reinforced section.
Okay sir, good night sir.
Okay, good night.
Thank you, sir.
Yes, good night, good night.
Thank you, sir.
Okay,
Good night.
Okay, good night, sir, good night.